if 2 cos y minus 7 sin x is equal to 3, and then cos y minus 3 sin squared x is equal to 2, find the real values of x and y in logarithmic form. So now we have 2 cos y minus 7 sin x equals 3. So let's label this as our equation 1. And we also have cos y minus 3 hyperbolic sine squared x equals 2. Let's label this as equation 2. So what we can do is that from equation 2, we can make cos y the subject, and then we'll get equation 3. So cos y is equal to 2 plus 3 hyperbolic sine squared x. So this is our equation 3. So what we'll do is that we'll then take this equation 3 and then insert it into equation 1. So 2 times 2 plus 3 hyperbolic sine squared x, then minus 7 hyperbolic sine x is equal to 3. So let's expand everything. So 2 times 2 is 4, plus 2 times 3 is 6 hyperbolic sine squared x, and then minus 7 hyperbolic sine x is equal to 3. So now let's bring 3 to the left hand side and get one equation. So we are going to get 6 hyperbolic sine squared x, then minus 7 hyperbolic sine x. Then if you bring 3 here, it becomes 4 minus 3, and then 4 minus 3 is 1, so plus 1 is equal to 0. So the equation is 6 hyperbolic sine squared, 6 hyperbolic sine squared x, then minus 7 hyperbolic sine x plus 1 equals 0. So now what we'll do is that let's let a to be equal to hyperbolic sine x. So it implies that this becomes 6a squared, then minus 7a plus 1 is equal to 0. So you see that this equation is of the form ax squared and plus bx plus c equals 0. So now what we will do is that, see that 6 times 1 is 6. So we will look for two numbers, and when you multiply you get 6, but when you add you get minus 7. And those two numbers are minus 6 and minus 1. So this becomes 6a squared minus 6a, then minus a plus 1 is equal to 0. So let's factorize 6a out. We left with a minus 1. Then here let's factorize minus 1 out. We left with a minus 1 equals 0. So in one bracket we have 6a minus 1. Then in another bracket we have a minus 1 equals 0. So the values of a are, a is equal to 1 over 6, or a is equal to 1. However, we said that a is sine x, so hyperbolic sine x. So therefore we have hyperbolic sine x is equal to 1 over 6. So therefore x is equal to hyperbolic sine inverse of 1 over 6. So 1 divided by 6. Or we have hyperbolic sine x equals 1. So x is equal to hyperbolic sine inverse of 1. So continuing from where we left off, we're having x equals hyperbolic sine inverse of 1 over 6. and then x also equals hyperbolic sine inverse of 1. So let's start with this one. We know that hyperbolic sine inverse of x is giving us natural log of x plus square root of x squared and plus 1. So hyperbolic sine inverse of 1 over 6, wherever we see x, we replace it with 1 over 6. This one becomes ln 1 over 6, then plus square root of 1 over 6 all squared plus 1. So now if we come down here, it becomes ln into bracket 1 over 6, then plus square root of 1 over 36 plus 1. And this is equal to ln 1 over 6 plus square root of 37 over 36. So now this is equal to ln, if you find square root of 36, it is 6. So this becomes root 37 plus 1 divided by 6. So this is one of the solutions to the simultaneous equation that we're given. Now let's find the other one, which is x is equal to sine inverse, hyperbolic sine inverse of 1. So x is equal to, the formula is natural log of x. So wherever we see x, we insert 1. So this becomes 1 plus square root of 1 squared plus 1. So x is equal to natural log of 1 plus square root of 1 is 1 plus 1 is 2. So root 2. So the other x value is natural log of, into bracket, root 2 plus 1. However, remember that from equation 3, we said that cos y is equal to 2 plus 3 hyperbolic sine squared x. So now, let's find the values of cos y to be 2 plus 3 times. We said that one of the sine x was equal to 1. So we replace here with 1 squared. And that will give us 2 plus 3 times 1 squared. That's 5. So cos y is equal to 5. So y is equal to cos inverse of 5. And then the other value of x is 1 over 6. So here too will be cos y is equal to 2 plus 3 times 1 over 6 squared. And that is equal to 2 plus 3 times 1 over 36. And therefore cos y is equal to 25 over 12. So this implies that y is equal to cos inverse of 25 over 12. So the values of y were y equals cos inverse of 5, and then y equals cos inverse of 25 over 12. So now, in terms of logarithms, cos inverse of x is equal to natural log of x plus square root of x squared minus 1. So cos inverse of 5 is equal to natural log of, wherever we see x, we insert 5. 5 plus square root of 5 squared minus 1. And this is equal to natural log of 5 plus square root of 24. So the other y value, that is y is equal to natural log of into bracket 5 plus root 24. And then y is also equal to cos inverse of 25 over 12. So y is equal to natural log of 25 over 12 and plus square root of 25 over 12 squared minus 1. So y is equal to natural log of, if you do all of this, you come to an answer of 21 over 4. So the solutions are x is equal to, remember now when x is equal to, when x is equal to hyperbolic sine inverse of 1, then y is equal to hyperbolic cos inverse of 5. And when x is equal to hyperbolic sine inverse of 1 over 6, then y is equal to hyperbolic cos inverse of 25 over 12. So now, in terms of logarithms, then x is equal to, we got sine inverse of 1 as natural log of root 2 plus 1. Then y is equal to the cos inverse of 5. We got it as natural log of root 24 plus 5. And then, so let me differentiate this as x1 and y1. This one as x2. x2 is equal to natural log, the sine inverse of 1 over 6. We got it as natural log of root 37 plus 1 over 6. And then we got the corresponding y value, y2, as equal to natural log of 21 over 4. So these are the solutions to the simultaneous equation. State the expansions of cos into bracket x plus y and sine into bracket x plus y in terms of x and then y, and then hence or otherwise express cos 2x and cos 3x in terms of cos x. Cos x plus y is equal to cos x cos y, then plus sin x, plus sin x, and then sin y. Then hyperbolic sine of x plus y is equal to hyperbolic sine x, hyperbolic cos y, then plus hyperbolic sine y, hyperbolic times hyperbolic cos x. So we are done with the first part of the question. And we are supposed to express it in terms, we are supposed to look for cos 2x and cos 3x. So now, cos 2x can also be written as cos x plus x. And that becomes cos x. We are using this expansion. Cos x, then plus sin x, sin x. So this is equal to cos squared x plus parabolic sin squared x. That is cos 2x. Let's do the expansion of cos into bracket x minus x. That is equal to cos x minus hyperbolic sin x sin x. That is equal to cos squared x minus sin squared x. And cos x minus cos x is cos 0, which is 1. So now you can see that we have two equations. This is equation 1 and this is equation 2. So what we are going to do is that we are going to add equation 1 and equation 2. So cos 2x plus 1 is equal to cos squared x plus cos squared x. So cos 2x plus 1 is equal to 2 cos squared x. We are looking for cos 2x, so cos 2x is equal to 2 cos squared x minus 1. So we are done with cos 2x in terms of cos x. Now let's look for cos 3x. So we have already established that cos 2x is equal to 2 cos squared x minus 1. So what is cos 3x? Now cos 3x can also be written as cos 2 bracket 2x and then plus x. So let's expand this. Cos 2x plus x is equal to cos 2x times cos x, then plus hyperbolic sine 2x sine x. So let me write this properly. So we said that cos 2x plus x is equal to cos 2x, then cos x, and plus hyperbolic sine 2x, hyperbolic sine x. Now let's do cos 2x minus x, which in other words is the same as cos x. So this is the same as cos 2x and cos x minus hyperbolic sine 2x sine x. So now let's add the two equations. Let's add this and this. So cos 2x plus x is the same as 3x. So cos 3x then plus cos 2x minus x is the same as x. So cos x is equal to 2 cos 2x cos x. Then this side becomes 0. Now we can bring this to the other side because we are looking for cos 3x. So cos 3x is equal to 2 cos 2x cos x, then minus cos x. But we have already found cos 2x. It is 2 cos squared x minus 1. So we are going to replace this by 2 cos squared x minus 1. So cos 3x is equal to 2 times 2 cos squared x minus 1, then cos x minus cos x. So this becomes 2 times 2 is 4. Cos squared x times cos x is cos cubed x. So there becomes 4 cos cubed x. Then 2 times minus 1 is minus 2 times cos x. So here becomes minus 2 cos x minus cos x, and therefore cos 3x is equal to 4 cos x cubed then minus 3 cos x. So differentiate the following with respect to x. The a part is log hyperbolic sine of x plus cos squared x. So now, and then there are b to d. So let's first start with the a part. So let's let y to be equal to log hyperbolic sine of x plus cos squared x. And then the next thing we'll do is that let's let capital A to be equal to cos squared x. But we know that cos squared x is equal to cos 2x is equal to cos squared x then plus sin squared x. And then we also know that 1 is equal to cos squared x minus sin squared x. So if we add these two, cos 2x plus 1 is equal to 2 cos squared x, and therefore cos squared x is equal to half of cos to bracket 2x plus 1. So now a equals cos squared x becomes a equals half of into bracket cos 2x then plus 1. So we can now differentiate a. So a prime is equal to, we first differentiate what is inside the bracket. So this is a constant, half times. If you differentiate cos 2x, you are going to get 1 over 2 then times, not 1 over 2. You first differentiate 2x, you get 2. Then if you differentiate cos, you get sin. So it's hyperbolic sine of 2x. And therefore, a prime is equal to, this 2 and this 2 will cancel out. So hyperbolic sine of 2x. So y is equal to log hyperbolic sine of into bracket x plus cos squared x. So y prime is equal to, you differentiate what is inside the bracket. If you differentiate x, you get 1. If you differentiate cos squared x, that is what we have already proved. It becomes hyperbolic sine 2x. And then you differentiate the whole sine into bracket x plus cos squared x. Differentiate sine into give you cos x plus cos squared x. But because we are differentiating a logarithmic function, we need to divide this by that function again, hyperbolic sine of x plus cos squared x. But there is a certain term that we have ignored, and that is, since this is log, we need to multiply by natural log of 10. Let me write it here, natural log of 10. Now, I have done a video on how to differentiate logarithmic functions. So if you don't understand this, you can watch that video. So y prime is equal to, now this is cos and this is hyperbolic sine. So cos divided by sine is going to give us cot. So here becomes 1 over natural log of 10. Then times all of this, which is 1 plus hyperbolic sine of 2x. then times cot 2 bracket x plus cos squared x. So let me rewrite it well. So y prime is equal to 1 over natural log of 10, then times 1 plus parabolic sine 2x, then cot 2 bracket x plus cos squared x. So the b part was given as AR hyperbolic sine of 2 bracket a cos x. So let's let y to be equal to AR hyperbolic sine of into bracket a cos x. So y prime is equal to differentiate a cos x, and you are going to get a hyperbolic sine of x, and multiply by the differential of everything. And if you differentiation, you get cos. So a r and then cos into bracket a cos x. Y prime is equal to, now a times a is a squared, so this becomes a squared r, then hyperbolic sine x, then cos into bracket a cos x. So the c part is exponent tan x plus cot x. So let's let y to be equal to exponent tan hyperbolic tan x plus parabolic cot x. So let's find natural log of y is equal to natural log of exponent hyperbolic tan, here is tan x plus cot x. So natural log of y is equal to, into bracket, hyperbolic tan x plus cot x, then times natural log of e, and ln e is 1. So ln y is equal to hyperbolic tan x plus cot x. So if we differentiate this, we differentiate y is y prime divided by y equals, if we differentiate tan x, we are going to get sec squared x, hyperbolic sec squared x. And then if you differentiate cot x, you are going to get minus cosec, that is hyperbolic cosec squared x. So y prime is equal to y, and y is exponent tan x plus cot x. So into bracket, hyperbolic sec squared x minus hyperbolic cosec squared x, then times exponent hyperbolic tan x plus hyperbolic cot x. So the d part is AR hyperbolic tan into bracket 2x over 1 plus x squared. So let's let a to be equal to 2x over 1 plus x squared. So let's first look for a prime. A prime, we will need to use the quotient rule in this case. So maintain the denominator, which is 1 plus x squared. Differentiate the numerator. If you differentiate 2x, you get 2, so times 2. Then minus. Maintain the numerator and differentiate the denominator. If you differentiate 1 plus x squared, you get 2x. Then divide it by the square of the denominator. That is 1 plus x squared all squared. So a prime is equal to 1 plus x squared. 2 times 1 is 2, plus 2 times x squared, 2x squared. Then minus 2x times 2x is 4x squared. All of that divided by into bracket 1 plus x squared all squared. So this is equal to 2, then 2x squared minus 4x squared becomes minus 2x squared divided by 1 plus x squared all squared. Let's let y to be equal to this function, which is AR hyperbolic tan of. Now, instead of writing 2x over 1 plus x squared, I'll write a, because we've already said a is 2x plus 1 plus divided by 2x divided by 1 plus x squared. So y prime is equal to, if you differentiate a, you get a prime, then small ar, and if you differentiate tan hyperbolic tan a, you are going to get the hyperbolic sec squared a. But then we know a prime. A prime is this value, which is 2 minus 2x squared divided by 1 plus x squared all squared. Then AR hyperbolic sec squared. Then a is 2x divided by 1 plus x squared. Evaluate limit as x approaches infinity of hyperbolic sine x divided by exponent x. So this is equal to limit as x approaches infinity. Hyperbolic sine x is given as half of, into bracket, exponent x minus exponent minus x divided by exponent x. So I want to bring this half outside. So half of limit as x approaches infinity. Then now it will be left with, into bracket, exponent x divided by exponent x minus exponent minus x divided by exponent x. So this is equal to half of limit as x approaches infinity. Now, exponent x divided by exponent x is 1. So here becomes 1. Then exponent minus x divided by exponent x becomes minus exponent minus 2x. So the limit becomes, so this is equal to half of limit, let me write it here. So this is equal to half of limit as x approaches infinity of 1, then minus half of limit as x approaches infinity of exponent minus 2x. So this part becomes 1 over 2 times 1, then minus half of, as x approaches infinity, exponent minus 2x will approach 0. So here 0, and this is equal to 1 over 2.